Hello, welcome to this tutorial series of design patterns. I am Balasubramanian. Today we are going to look into a creational pattern which is factory method. So let before jumping into what is factory method, let us understand what problem does creational pattern solves. Creational patterns abstracts the object creation from the creator. So the first step the creational problem solves is we are outsourcing the object creation to a separate place where the objects are created and returned. So, how it helps? So, it helps in decoupling the creation from the creator. Suppose that if we are instantiating an object with new, the where the place where we create the where we instantiate is coupled to the concrete class, and if we have to change certain parameters of that concrete class, it would directly affect the place where it is getting instantiated. So such kind of coupling problems are resolved by creational patterns. And there might be other things. For example, if we are creating a complex instance such as a instantiating a connection which involves probing through the port and then getting the URL and then connecting to the endpoint, which is a complex process. So we can hide such kind of instantiation, such kind of thing while we use creational patterns. So let us look into the example which would be very clear. Uh, So factory method. So what is factory method? Factory method pattern is a creational pattern that uses factory methods to deal with the problem of creating objects without having to specify the exact class of the object that it is being created. For example, if you have to create an object of a, type burger, which is fast food, we don't need to say that okay, give burger b food fast food f equal to new burger. We say that get me an object of this type. When we say, the object would get created. That is the purpose of a creation factory method. This is just an example. We'll look into the concrete example later. This is done by calling a method which creates an object. So as I said, when we create an object, we just pass in what is that type that we need, and the factory method returns the object back to us. So the object returned by factory methods, so as a small type, factory methods are called as products. So why are they called products? Uh, So, the factory method creates an object of a class which inherits from a same parent class. So, so it returns an object of some of a subtype of a parent class. So that is why we call it as a products of certain type factory, right? So think this as a factory where it returns products, right? A factory manufactures products, products of similar type. So when we go and instantiate an object with a factory method, ideally it should return a product of a subtype, not a product of a different type. So factory methods are not used to instantiate an object of a complete different type non-related type. So factory method returns an object of a type which belongs to the same uh, parent type. With all these things, let us directly look into the UML diagram of it. Let me minimize this and maximize this. So today we are going to look into a notification uh, type of example where there is a notification client which has a, if we see here, there is a interface called notification client, and it has a method called notify. So there are different types of notification that we can send. One, think of as an email notification. The other is a short message notification. The other you might think of a Slack notification or whatever it is. So we might be sending different types of notification. And when we need to send a notification of a particular type, we need to instantiate a appropriate notification client which would help us to notify to that particular client. Think of a think of an order processing system. Once the order is processed, the customer may give that, okay, send me a push notification if I am online. Otherwise, send me an email as well as a short message. The customer may subscribe to different types of notification, and once the order processing is done, the order processing system has to send different types of notification. When the system has to send different types of notification, we need not go and instantiate these notifications as new. We will go and ask to the factory that give me the notification client of this type. For example, give me the notification client of email type, give me the notification client of short messaging, give me the notification client for push notification. That notification factory, which is the factory method, takes in the type and instantiates that appropriate notification client with the parameters that it has to pass. For example, this port might be mentioned in a configuration file, or we might have to get this configuration from a zookeeper, or appropriate backend configuration might be in from database, and then instantiate it. It seems to be a little complex process, and we need to abstract it out. Where whoever wants to send a notification, they need not go and get the configuration from some other database or a configuration file, which has to be exposed to the creator, or which has to be exposed to, which need not be exposed to the creator or the notifier, right? So whenever if we have to move the configuration from database to a configuration file, or from configuration file to a separate key value store, to a separate file system or an external file system, this would involve a lot of changes in these concrete classes as well, because these concrete classes, such as this notification sender, will have to know that where I have to get this configuration. So it is good to abstract out these properties, and then enable the come up with a creator who is going to create the notification client for us, and then we will call notification client with an appropriate notify method with the parameters that we need to pass. For example, what is the purpose of the sender? The sender has to send a notification which who is the recipient of it, who is the sender of it, what is the message body. That is the thing which the sender will know and has to provide. The sender need not know about where the destination port is, what is the protocol that I need to do, what is the host, right? What has to be notified is what is the sender will know, and the sender has to know. Rest all things can be abstracted out. This is abstracted out with this factory method. So with the, I think the explanation would be clear. So let us dwell deep into the UML diagram. The notification client is an interface which has a method called notify, using which we will be notifying. So this notification client is an abstract notification client which implements this notification client method, which has a notify method, and the client has a destination port, protocol, host. There might be other properties, but for the sake of example, I've come up with three properties. And these properties that is there can be from a different file, different, as I said, it can be from a database, and it can be from a etcd key value store, which we can go and fetch. So there are concrete implementations of this client. One is email notification client and SMS notification client. There might be other types of notification that we can come up with and send as need be. So the notification factory abstracts the client, and it enables the object creation processor. The notification factory takes in a type of this client, and it gets the notification client, or it instantiates this notification client and returns the object. Once this is instantiated, and since this client implements this interface, the notification client interface, the caller can call after the notification client is instantiated. The caller can call notification client and notify. using the message header, footer, recipient, and the sender. Message header, footer, recipient, and the sender. These are the 5 properties which they use, which the notification to which what is the message, what is the header, what is the footer, recipient, and the sender. And using these things, the messages will be passed on to the appropriate recipient. I think this UML diagram is clear. Let us go into the implementation part of it. Uh, let's directly go to the notification. As I said, notification is the notification class abstracts the notification which has to be sent to client. So this is the most important thing that we have to understand. Message, it contains message, header, footer, recipient, and sender. It has a constructor which takes in all these parameter and initializes it, and it has getter methods. It doesn't have a setter method because these are the properties which are required for this object to be instantiated. Without any of these properties, there is no point in instantiating a notification. So I've just come up with a constructor based initialization. There is no setter. We will have getters. So let's go to the notification client. A client implements a notification client. So what is the notification client interface? Notification client is an interface which has only one method, which is called notify. This method takes in the notification which we saw just before, which contains the message, header, footer, recipient, and sender, and notifies the appropriate recipient of the message. Okay, so this is a simple interface. So let us go to the client. Since this client implements this notification and this is an abstract class, so the concrete class will implement what it has to do, how the notification has to be sent. For this client to be instantiated, it has 3 properties. What is the destination port, what is the protocol, and what is the host. So these all are initialized via the constructor. Let's go to the email notification client. So the email notification client extends the abstract client, and it takes in these parameters: destination port, protocol, and host, and it instantiates the superclass of it because it's an, and since it implements this client which implements this interface of notification client, so we have to implement this method here. So in the notification, rather than me calling an API which is a HTTP API or call a SMS client API, I am just saying, printing out that the notification is sent, sending from this sender and sent it to this recipient. Just like that I am printing. In real-time scenarios, or in the use cases that we are going to implement in production scenarios, we will say that we can call an API here saying that, okay, go and notify this, and all the other implementations may come here. But for the purpose of this tutorial, we are just doing a println. It is as good as calling any other client as well, right? Similarly, we have another SMS notification client which also takes in 3 parameters, which is the port, protocol, and host. So these are all this is the concrete class. For this class to be instantiated, we need these 3 parameters. When I have to send a message, I need to know which port it is, which host I have to send, what is the protocol, right? The protocol contains what is the header, what is the message, what is the body, and other things. So if we take the HTTP protocol, how do we communicate? It will have HTTP headers, it will have the HTTP body, and whatever it is. So similarly, if it is a SMTP protocol, which says that who is the sender, who is the recipient, and what is the body, how the body is formatted, the protocol defines all these things. In real use cases, protocol is a complex object, but for the purpose of this tutorial, protocol is string. So forget, means we need not concentrate too much on that abstraction. Here what it takes a sending notification. The implementation of this notification is simple, and sending a we can say that sending a SMS notification sending a SMS notification to. So here previously we can sending email notification. So till this time we have just looked into the overall structure of it. We have not looked into the method which creates it. Let us look into the factory method which creates it, right? because if we take the email notification client and the SMS notification client, instantiating of those clients will require some additional properties which has to be supplied at the time of instantiation. What are those properties? If we take we need to know the destination port, protocol, and the host. And as I explained in at the start of this tutorial, this might not be available directly to us. We might have to fetch those details either from the database or from the configuration file or whatever it is, so that when we if the port or anything changes, it requires less change in the system. uh, so 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 what we do is we outsource this instantiation to a factory method, which is get notification, which is a notification factory which instantiates the objects based on the client types that we are passing it. So here, what is client type? Client type is a simple enumeration. If I have to send an email notification, say that okay, get me an email client by passing this enumeration, so it is going to create the email notification client. So we don't need to specify any other thing. It's just an enumeration, right? So we say that okay, get me a client of this email. So we are instantiating the object here by passing in the port, what is the protocol, and what is the host. So SMTP port is 25. I've just used 25 as the port name and say SMTP as the protocol, and then what is the destination. In terms of SMS notification client, the SMS notification usually being called via HTTPS endpoints, and from that UDP notification is sent. So I'm just saying that 443 is the port, and it will be HTTPS, and then we use a gateway to send a SMS notification from the web service that we are getting. Assume this is a web service. So the default note, there is no default notification client, so I'm just returning null. So consider in this real-time scenario, if you have to go and fetch all the port details from the database, it involves additional code, right? If we have to couple this to the creator, it would involve additional code at the place of creation. And if we have to change this object creation, or if we have to change the instantiation, or if you are moving from one place, the fetching the properties from one place to the other place, it would involve additional code which is coupled to the client, which is not required, right? So this factory method decouples the creation from the creator. I think if we understand this, and the creation, we should create objects of similar type. We cannot create objects of disparate types, right? Get notification client should return a notification client, not some other object of a different type. So usually it is of that. If we understand this, and the purpose of factory method, we will be understanding, and it is widely used. Factory method is a widely used creational pattern across the entire software development life cycle. We would see this in many places. Um, One such example is executor service. There we can call fixed thread pool. So the executor services uses a factory method to create objects. So let's go to the instantiation main part of it, right? Notification main. Here, what are we doing? So we are creating a notification which has to be sent, right? So ideally, we have to create what notification you have to send. I'm saying the notification is a new notification which has the first method is the message. First parameter is a message. The second is the header. The third is the footer. Fourth is the recipient and the sender. So we are creating an email notification. We are instantiating an email client. So we are instantiating an email client here, and how are we instantiating it? We call the notification factory.get notification of client type.email. We use this enumeration to create the to get an instance of this email client, and then say notify. Whatever it has to do, whatever this email notification client while instantiate it has to do, it is outsourced to this factory method. So there is no coupling. So the creation is decoupled from the creator, right? So who is the creator? Factory is the creator, and the creation process is decoupled from the client. So since it is decoupled, it is easy for us to test. if you have to check, if you have to test whether this returns an object of the factory method should return an object of email client, the testability becomes very easy. So pass in this, we will be able to get it. That's also another use of it, right? So if we are creating an object here as well, the testability becomes difficult. So we would be able to we have to separate these two methods. But first is creation and the other is notification. Unnecessary overhead, because the purpose of it would also violate single responsibility principles, right? We don't need to have a class which creates a object of certain type and then send notification, right? So ideally you should have a class which sends the notification, not creation. So this, since this creation is separated out to a different process, so testability also becomes very easy. That's the other use of it. I'm just calling the notify method. The second time I'm creating an SMS notification which has a message, header, footer, recipient. For example, for SMS, footer might be null. I'm just saying a signature, and the recipient would be not an email ID, but it's a phone number, and the sender is an abstracted 6 digit. If we have to send bulk notification, this is how the API gateway accepts. And I say notify. The notification is done. Let us run this and see. Execute this and see. The first thing is sending email notification. So it created an appropriate instance of this email and sent an email. The second time it creates an appropriate instance of SMS and it sent. So when we go to SMS notification, so the problem is it creates email. I have to put SMS dot message. That is why you are seeing email. So there was a small typo. See, if we see it, first place it is sending an email, the second time it sends an SMS notification. It instantiated the appropriate type and then it sends. I think with this explanation we have come to the end of this tutorial. Uh, I would reiterate the use of the factory pattern. Factory pattern decouples the object creation from the creator, or from the client, right? So the object creation is abstracted out, and factory method helps in decoupling the creation from the creator, and it also brings in testability. And factory method creates an instances of related types. These are the things that we need to keep in mind while we are using factory pattern. If you like this video, hit the subscribe button, and thanks for your time.